lot of work today, guys. Now keep in mind that handout you have, I will have these steps typed on the test or quiz when you have one. We want to memorize going through all that. I'll have to type it for you. I think number one, Andrew, if I'm correct here, was please list the domain. Is it true? Always, step number one says list the domain immediately. Now I do see this one can be cleaned up a little bit, factored. And guys, in terms of factoring, I could on top take out a common factor of 3x. And watch my factoring carefully here. Denominator, I think it factors into x plus 4, x subtract 3. Now tell me in the blue, based on the blue, what would you say the domain might be? What's my domain? X cannot be what?
-4 3.
That's all I need to hear. X cannot be -4, +3. Now you can place that in integral notation if you wish, but we're at a point where we have so much more work to do, I'm satisfied with that. Could put it in integral notation. Number two, Andrew, if I remember correctly, I think it says to simplify this.
Yes.
Which we've already done. It's the blue. Let's rewrite what we have there from the blue. That looks like this. I give you credit for that. Step 3, if I'm not mistaken, it says please find the x-intercepts and the y-intercept when I get to the graph. Guys, the x-intercept, you know to set y equal to 0. If I set this equal to 0, can someone tell me right quickly, and I can do a little cross multiplication or clean it up, what will that lead me to down here in the attempt to find the x-intercept? What do you think it'll give me? What do you think is putting me? I'll go put 0 in. This is the way we find the x-intercept always, for all functions. But what do you think this will look like? That's what it means. What do you think it's going to look like if I clean it up? In other words, solve it. Yeah, just a little cross multiplication. Put that 0 over 1, you can. Fast way to do it, or use a denominator. You're going to end up merely 0 is equal to this. What my students, not too many semesters ago, said, Professor, I think the best way he remembered it was, he says, just set the numerator equal to 0. So that's what always comes up to me down here. Just set the numerator equal to 0 in an attempt to find the x-intercepts. If I do here, guys, I think, I hope you can see it back down on the board here, take out a common factor of 3x. I think you get that. 3x times x minus 1, yes or no? Now, if you split that up, please tell me, what will I identify as my x-intercepts? 0, let's write a 0, 0 as an ordered pair, and I heard also 1, 0. True? That's done. You get partial credit for all this. Now, the y-intercept will be easier. You go back to your function and find r at 0. Replace all the x's by 0. Guys, we'll do it here. I'll get a 0 on top in that numerator, and it looks like maybe a -12 in my denominator, which really says 0, which we might expect. The y-intercept is 0, 0. Look at all the partial credits you have already. Number 4, Andrew, I think, remind me, was it vertical asymptotes?
Yeah.
Here we go. Use the abbreviate. Make this done. And I think on your handout it says to find where those are, so when I get to the grid, set the denominator equal to 0. I'm going to set my denominator, this, equal to 0. And guys, we left out here, this will factor. That, split this up, we'll have one vertical asymptote at -4 when I get to the grid, and also one at 3. Or partial credit. Now Now, the one that might be difficult, I need one more here for today, then we grab it. The next one could be a little trying on us. This is horizontal asymptote. By the way, guys, before I jump in and finish this up, we're closing down, is this closing down the third week of school already? Right? In a regular semester, you know when they finally see this? And I'm talking about 16-week. Let's say 16 weeks started in, I think back on the fall there. I guess we started late August, probably November. Maybe end of October, November. Is when we finally got to this in the regular semester. Here you are getting to this, what, third week? But it's short session, so it moves fast. Horizontal asymptote. Now, that's the hardest one of all I have, and we'll go right there. Anyone tell me what am I asked to do, if I can, to find where's that horizontal line that's going to help me in math? Henry?
You divide all the terms by x squared, both top and bottom.
Why x squared?
Isn't that because it's the leading coefficient?
Yeah,
Not the
yeah.
leading coefficient.
What is it, the highest?
Yeah, the highest term,
Okay,
yes.
so let's go through it. Exactly, he's right. So let's take each one of those terms and divide as you gave me by x squared, and we'll simplify later. I think your calc instructor will show you something like this also. And right now, I know it looks messy. This is the hardest part of the parts we have today, but we did it. Andrew, thank you, that's exactly what I'm gonna do here. Now, if I simplify after dividing everything by x squared, these cancel, which will help. This turns into what? One of these will cancel, 3 over x. These cancel into a 1. X into x squared makes this 1 over x. I'm just simplifying. This is strange. I can't do any canceling on that last term, but I could be clever and rewrite it as 12 times 1 over x times 1 over x. Can you guys see all that? Can you see what I did there? Now, why I bring that 1 over x in, what I think I was using that as my parent graph. And what did we notice about the 1 over x? As x gets large,
It equals 0.
yeah, this drops out. The 1 over x will drop out. So where I see a 1 over x, that's why I do it. I get to drop that out to a 0. Now keep in mind, guys, I still have 3 here. Nothing drops out there. This was, I think, 3 over x. Bear with me. Which could be written as 3 times 1 over x. And therefore, this is 0, based on the parent graph. And therefore, this drops out. This is gone. 1 stays right where it is. Take the thing with it. 1 over x, oh, that's definitely 0. Drops out. This one, the way I have it written, would be 12 times 0 times 0, which is 0. It drops out. Does it make sense the way we drop these out? I'm left with what? 3 over 1, I think. Am I? Am I left with 3 over 1? So all this tells me, after I simplify it, I've got 3 over 1. Guys, again, now this dropped out, this dropped out, this dropped out to a 0. Now I'm left with 3 over 1. So my horizontal asymptote would be located up at, I'll put a Y here, up at 3. Yes?
I have a question. So on the numerator,
Uh-huh.
so that it was 3 times, and then what happens to the negative
Where was it now?
in the numerator?
Up here.
Yeah.
Here. Okay, did I copy that wrong?
No, I'm just like, it just,
Okay, these canceled. I got 3.
Okay.
And then x into x squared gives me an x down here. So that's like saying this right here.
Where does that 3 go?
Ah, the 3's in front. Why do you could do like this. I got you. You do right like 3 over x.
No, but where did it go? Because it'd be 3 minus
Ah, beautiful, 3
3.
times 0.
Okay. And what happened with the other thing?
And the 3 here, that 3 stays where it is. Why? Because these canceled out completely. There's no 1 over x there. Oh, I see what you're asking. Yeah, 3 times 0, that's why it dropped out.
Okay.
Good question to you. Right one, where did that 3 go, Professor? Because the 1 over x was 0, then 3 times 0 gives me a 0. This 3 stays where it is. That x squared over x squared factored out nicely for me, and the 1 down here, of course, stays like it is. Guys, I know it's a little strange. We'll do a little recap tomorrow on this. Got anything else on this? If not, and this is the hardest part right now. We'll do more of it tomorrow. Let's put all this business together and get a graph. See what this graph may look like. Okay, guys, here goes. Let's pick up what we had. Going back to the very beginning. We got domain, we got that. X-intercept. 0, 0, and 1, 0. Makes the here. That's left to 1. Here. What else do I have here? Y-intercept 0, 0, got already. Those vertical lines, vertical asymptotes, are located at -4 and a +3. So let's go out to a -4. -4. You guys want to show those in red for a reason, but I cannot let the graph touch these vertical asymptotes. So -4, I think it was. This. And we have also 1 over 3 placed on this. You guys can get a sense of, I think, how tedious this is and how difficult it can be at 3 here. There's the vertical. Horizontals, the last thing I need to worry about, that's up at 3. That's a strange one. There. And we put that in a different color, let's try green. And we'll try to graph this. Step back and look at this. I know it looks a little strange right now. We will make it work. Now start from left to right and try our best to see what on earth is this graph going to do. Wow. Let me extend my green here. Should I test a point to the left of -4 and see where on earth is my graph? Or does someone have an idea of where that piece might be located right now? Any ideas? Or I'll plot a point.
Does it have to really be exact for you, or just like a general?
Just general, yeah, just a little shape. Okay, but locate where? Tell me, where is it located? Is it located in here? Or is it located up here? Okay, I'm here. PK, you're saying, I haven't plotted the point yet. You're saying, Professor, go up here and follow those asymptotes. You said it might be up there. I'm gonna plot points to see if I do get that up there. Can anyone tell me before I plot a point to confirm her answer? Why might it not, I'm gonna put this in here then, guys. Why might it not be in here and doing this? And follow that red and the blue, green. That follows the green, that follows the red. I didn't let it touch the red. Why could it not have done that?
There's no intercept.
There you go, you'd pick up another x-intercept, wouldn't you? And I have my x-intercepts already plotted. I don't have no extra x-intercepts, so I can't do that. PK, just for the sake of students, with what you gave me, I agree with you up there. I would do this real quickly. I mean, it just takes 1 point. I would try maybe a -5. A -5 here. And take it back real quickly and replace it. I know it's gonna take a little time here. In fact, it might be easier in the factor form. Replace x by -5. Guys, I see a -15. I see a -6. I do not mess up on the arithmetic here. That's a -5. -5 plus 4 is -1. Side about this -1 here. And then -5 subtract 3 is -8. Let me step back, I did that real quick. Replacing all the x's by -5. And I think those are my numbers I have to work with. I got 90 over 8. 90 divided by 8, is that 11 point something?
Yes.
Is that definitely above 3?
Yeah.
So it's up there. Definitely above 3. Now, before I leave it, I better identify this right here. This is representing 3. Now, does anyone think they know what's happening in between where you gotta pick up these two? Now, you may want to plot points. But does anyone have a guess as to what it looks like in between for the next piece of this strange rational function?
We have x-intercept and y-intercept.
Say it again.
We have x-intercept and
We got the, beautiful, we got these two to work with. Now, Grant, let's go through these. So, what does the entire shape look like? Caught between, and it's got to pick those up. Yes?
Could it be a downward facing parabola?
Whoa, now I haven't applied any points. I'm here at this. You're saying, Professor, it might be a downward, facing down, opening down parabola, and you got to take them here and show that it's not going to touch this. You tend to go up like that, probably across and come back down, and down that way. You think something like that? Not a true parabola, but it looks something like that. You could plot a point to make sure, to confirm what was given to me, what my student gave to me. You can do that. That's just plot point to a table or whatever, and I think to save us a little time here, I think that's correct. Now, does anyone have an idea what on earth to finish the graph up is going on over here to the right? So,
Is this the same as the left side?
thank you. It's gotta be up here. Now, I didn't plot a point. To confirm what Phil gave me, I could plot a point to make sure it is up there. And also, I could plot a point here, or a couple points here, to make sure this middle part is correct. Andrew?
Is it a parabola because it's an x squared?
Oh, whoa, whoa, as soon as you see an x squared, all students, me as an instructor, if you see an x squared, you'll say, x squared, must be a parabola somewhere. Maybe hidden, but I'll find it. It looks like an x squared. It's yelling for parabola. And this one does take a, what they call a parabolic shape. I don't think it's a true parabola.
No.
No. But as soon as you see that x squared, you may say the shape of it maybe.
Yeah.
Yeah.
Okay.
You're right. Guys, anything else? I'm glad we got this one. This one seems to be a little bit easier than that first one before we took the break. Yes, Keith, how's you?
Are you basing that off of the x squared or the fact that the sum of the exponents on the x's is even?
I think Andrew was just looking at, as soon as he saw an x squared, he thought, oh, Professor, maybe x squared is associated in my mind with the shape of a parabola, so I might expect a parabola to come up.
Well, 'cause the last
Not
one-
always, but it's, in this case, yes.
The last one we did was like a little snaky type one.
And was there a cube involved there?
Yeah.
Well,
Was there a cube involved there?
No, but all the exponents together was a cube.
Oh, all together?
Yeah, and all the exponents on this one together is a 6.
Okay. Andrew, I would still though suggest that you maybe plot a few points just to make sure. Okay? Guys, that's a strange looking graph, but that's it. Now, I could ask June and Mr. Park, what on earth did the calc instructors ask you to do after this? Because they're gonna say, Ramsey already shown you how to do this. They're gonna say, do it quickly. They'll say, oh, it took Ramsey 15 minutes to show us just do this. You don't have 15 minutes in calculus. They're gonna say, do it. And then, their, concern is, now we're gonna do some calculus on this. There's some calculus to be done on this after. Okay? Guys, any concerns here? Okay, now I think we got did we get the domain out of the way? I think we did the domain. Range, I would not ask you for the range on this graph. Tell me why. I may not ask you about the range, the up and down on this particular graph. And that drops down through negative infinity. Is it true? It goes up to where?
You'd have to find.
Yeah, you'd have to find
maximum.
where that point right there in there is. Probably like a local max in there somewhere.
Yeah.
And we don't know where it is. And you can't find it until you take calculus. Then you can answer it. But right now, you can't give me that range. I would not ask you the range. By the way, the top part's easy. The range is what? 3 through infinity.
Yeah.
So they were both 3. 3, comma, infinity. Okay, guys, we'll stop at that. Oh my goodness, I'm checking my time here. I'm getting a little nervous. I did what I had to do. But, I have, your professor stays busy. I had this, and this. Hoping that I would be able to pass out all 3 of these and get into chapter 5. Not gonna happen. Not gonna happen. We're not gonna rush anything. It's not gonna happen. So I'm happy right now with where we are, and I'm gonna take, let me see if I'm ready. I got about, what, maybe 5 more minutes before I'm gonna slow down and show you guys. Some of my students are saying, Professor, when I pick that handout up, and it says review for exam 2, I guess, right? And I looked at it, I smiled, I said, my goodness. There's one side, and then I flipped over, and the answers are on the other side. Professor, this is gonna be the easiest test ever. I'll get an A for sure. And I sat there, I knew what you were thinking, but I didn't say anything. I didn't say anything. You know it's gonna cover more than that. By the way, can anyone remind me, I won't jump into the review, guys. Anyone remind me what sections are you responsible for on this exam tomorrow? I think it starts out with 2.3.
2.3.
Hang on now, look at this one. 2.3. 2.4, I think it's listed. 2.4, 2.5.
6 and 7.
Oh, yes. Now you gotta keep in mind, you're very fortunate, SMC is so great, but when you go off to a university, they're gonna just list the sections and say, good luck. Then they're gonna do a review for you. Your test covers 2.3, 2.4, 2.5, 2.6, 2.7. See you tomorrow for your test.
For the review thing, the answers only go up to questions.
That's because you haven't seen the other questions yet. That's what I gotta show you today.
The other questions are already there.
No. Oh, no, I see what you're saying. They're on there, but I don't have the answers to
Yeah,
them.
there's
Gotcha,
no-
I wanna look at it. Andrew, we do this, if you mentioned it, but I do have from here I want to look at first myself. Okay. Guys, exam 2 tomorrow. I'm working on it. I'm trying to have it to be an hour and a half. Usually your exams are 2 hours. I'm trying to cut down and not have such a lengthy test, but yet cover all the topics, but not have as lengthy of a test. And maybe give you about an hour and a half, because I need some time also myself to finish up what we're doing right now with those rational functions, and hopefully move on from that into chapter 4. Okay? Now, so Professor, what else? My goodness, what else is gonna be on that exam? Did I start out with a completion of the square again? Was that on the handout, complete the square again?
Yeah.
And we did it on the quiz last night, didn't we?
Yes.
Oh my goodness, Professor, you're gonna make me do completion of the square again? And I'll do something with completion of the square, definitely. I may not be as much detail as you did on that quiz last night, but you did such a great job. So, yes, it's on there. Now, what else is on there, Professor, besides what I see on the, handout? And Andrew said some other things I have not yet looked at, right here. Andrew, as I write this out, you'll have some, or an exercise that may do this. Determine I think I just phrased as, yeah. Determine without graphic, no graph required. On this. And looks like I'm asking for the max or min value. Maximum or minimum value. Now this, you can't go wrong. You cannot go wrong. When I score your papers, if you went wrong, I'm gonna write your paper. You went wrong. You cannot go wrong on these, not this part. Why? I brought in just a couple of examples. If my function looks like this, f of x is equal to a negative 2x squared plus 8x plus 3. You know that's going to be a parabola. It's quadratic. I'm not asking you to graph it. For goodness sake, we're not going to complete the square and go through all that business. I'm just asking you, is there a max on that graph without graphing it? Or is there a min? First one to identify, in this case, is a max. The parabola opens down. So I'm looking for the maximum value that this function takes on. I hope you'll say, Professor, no graphing? No graphing. But you use this. Negative b over 2a. That's all I'm asking you to do. And if I replace, I'm looking at negative, looks like 8 over twice a, twice a negative 2. And guys, looks like, help me out here, is that positive 2? Now keep in mind, that's not the answer I'm looking for though. What must I do now? I have a choice. You can use 4ac minus b squared over 4a. That's actually what I'm looking for. Or, I could, what, substitute or plug in f at what? 2. I think most students might do it this way. It's up to you though. Replacing x by 2 and do the math here. Looks like negative 8 plus 16 plus 3. Guys, help me out here. Is that 11? I do that quickly. Is it 11?
Yes.
And that's the answer I'm looking for. That's the maximum that that function will take on no matter what x you put in there. In fact, when you put 2 in there, you reach that maximum. But that's the maximum. No graph required.
You don't want it as a point?
No. In fact, they're asking probably now at this point, they just want you to list the y value. And I realize it's x equals 2, but really this is the answer right here. That's the highest of that graph. If you were to graph it, that's the highest the graph can go, up to 11. That's called the maximum. I had one more. Did I have one more? I did. It looks a little interesting here. Did I have some of these on the handout, by the way?
Yeah.
Oh, I did. Andrew.
Yes.
Give me one from the handout. This is the one I brought in. Was that on the handout?
There was one similar to it.
Okay, how about another one? Different one.
Well, there's one where it's g of x equals pi x squared plus pi x plus 1/4 pi.
1/4 pi? Oh, why not? No graphing. That's a quadratic. And does that quadratic take on a min or a max? And it looks like in this case it will be opening up. So that's what, a minimum? And you say, Professor, how can I find that? Same process. On the side here, we'll let x equal negative b over 2a. You may end up with something a little strange here. B is pi. 2 times a is also pi. You end up with negative 1/2. It's canceled. That's doing this quickly, don't mess up. Now, is that the answer? No, you're not quite finished. Put a comma here, now you need to find, G of negative 1/2. You guys can go through and replace, by negative 1/2, and be patient. We're going to do this, that's gonna be 1/4, should be a little time, b squared. Now, negative 1/2 pi in the middle. Now replace x plus 1/4 pi on the end. Step back and make sure all that is correct. I think it is. You guys agree? Do it quickly. Oh boy, we got 1/4 pi, another 1/4 pi. Well, that's 2/4 or 1/2 pi, is it? But those two together, that's 1/2 pi, and then I got to subtract 1/2 pi. So what is it? It's 0. That's the minimum value that this function will take on. 0. Everything cancels. And things like that could happen. Okay, so I had to do that. That will be on the test. Okay, part 2. Routine here to follow. Yes, solve. Here we go. No, Professor. What we're gonna do now, you're gonna do this. X squared plus x is greater than 12. Yes.
For the last one, I know it's longer, but if you put it into the vertex
Form?
form,
You got to divide everything by pi first.
yeah, but then you can still use that answer.
Oh, I see, you get rid of the pi first, and divide everything by pi and get that leading coefficient to be a 1, and then do it. I would say you better just keep it in raw form, you see. I see what you're doing. Yeah, I'm doing personal form. Guys, here, x squared plus x is greater than 12. I've got much time here. You know at this point, if you see something like this on the test tomorrow, you're gonna move this over. You know you're gonna factor. We've had these before, but we're going to see them again. Through there. And then someone tell me, what would you do from there? Sign analysis. Now, I may not on this test put on the side there, use sign analysis. I'm going to just assume you would know to use sign analysis. You guys, on the side here, do it quickly. Save a little time here. You got what? Negative 4, and a positive 3. And they are to be open. Step back, look at it. Yes. Now, I'm going to do my testing real quickly. Okay? Out to the left of negative 4, I'm going to try negative 5. That would be a negative and a negative. Is that true, guys? I think it's a positive altogether. But that just to save a little time. In between, we'll try 0, put a 0 in, I see a positive times a negative. That. Out to the right of 3, we'll try 5. Now that's going to be a positive. Now that should be enough to answer the question. Put a comma here, my solution would be negative infinity up to a negative 4, open, union 3 infinity. And you're done. We've done these before. Part B. A few more here to look at with you. Next one looks like this. 4x squared plus 9 is greater than 6x. Like to solve that inequality. What would you suggest first on this one? I have to move it 6x over, put it in the form you need it. Minus 6x here, plus 9, exactly, greater than 0. Now, will this one factor? If not, I'll use quadratic formula. Step back, look at it, I'm hearing no. True? What? might you think it would factor into? Tell me what I see a lot of students thinking it would factor. They're thinking it may factor into this. Does it? So that's the most common thing I see when I score papers sometimes. They think that this will factor into this. Is that true? Will not factor, will not check it there. Can't factor it. So what am I supposed to do? You gotta use quadratic formula. So on the side here, that's why I brought this in. X is equal to, by quadratic formula, guys, here it goes. My number's in. You'll probably end up with a 6, and I'll get out of your way here in a second, guys. Square root b squared is 36. Subtract 4 times a is 4, and c is 9. Do not let me put anything in correctly here. All over 2 times 4 is 8. Let me step back and make sure. 36 minus 4 times a times c, that looks good. Are those the numbers? Did I put the numbers in correctly? I did quickly. Now, what's the issue?
It's gonna be a negative.
That's a negative underneath that square root. So, what might you say?
You're gonna have to use pi I.
Oh, no, I'm not solving this.
It's on the real number.
Yeah, okay, I got that. There's something a little strange here. It says you're solving this inequality. I heard I heard an I coming out, Professor. By the way, there would be an I coming out if you were going to go ahead and solve this thing. If this were an equation, not greater than,
Oh, yeah.
you'd have an I in there for sure, for an answer. Now, something's going on, that's the reason I brought this in. What's going on here?
No solution.
I would think most students say no solution. Well, let's think about this. This tells me right here there are no x-intercepts. Is that true?
Yes.
This right here says there are no x-intercepts. Y-intercept on this, we replace x by 0 somewhere in here. Do you get a 9 maybe? Is that true? I think.
Yes.
Yeah, so there's a y-intercept but no x-intercepts. Whatever it comes down to, it's going to look, I'm not going to do a specific graph, but here's a picture of it, guys. It's not going to have any x-intercepts. It opens up. Is that true? Where is it located? It can't touch the x-axis.
It's okay, that's not.
Must it be above here somewhere?
Yeah.
Is that true? I think was the y-intercept short of 9, I think? Was it? So it must have graphed through something like that? Yeah, let's try to answer the question. The question is, when is that graph above the x-axis? Always.
So it's just.
Always. Therefore, the answer is not no solution, but what?
Negative.
All real numbers are negative infinity through positive infinity. It's always above the x-axis. Now, that was one I had to bring in and discuss. Okay, so guys, this just more basic here, sign analysis. This one a little strange. Take a look at it. I'll be here 11:30 tomorrow. Do more of these. Expect some of those. Let's see what else I got here. Oh my goodness, yes. Next part. All of the more here. Part 3. We're going to have at least one on that test word problem. Now tell me what I could choose. I could choose anything, but what might I choose based on what we've done in class for your word problem? What type of word problem did we work out that used max or min or whatever? Yes. There you go. The object being tossed up somewhere. That's true, guys, and it follows the path of a parabola. And they ask you what's the maximum height, and how many seconds it takes you to get to that maximum height. Did we look at that? That could be it. So in there, something else that we did look at that could be a nice word problem.
Yeah.
The fencing. I think we went through one day about fencing a piece of land here at SMC or something, trying to find the maximum area, so forth and so on. So probably more than likely it'd be one of those. I could choose something else though. I have another one in mind. It's nice. Those are the two I think we focused on in class. Part 4. Ramsey, how much more is there? I'm about to finish. Here we go. The absolute values. The absolute values is in 2.8, if I'm not mistaken. And I'm gonna look at some right now with us. First, look at this one. Solve this. Absolute value. I've got x squared plus x is equal to 12. Now, we did these in class. You guys seem to really do these fairly fast. Anyone remind me of the routine that we need to do that?
X squared plus x more equals 0.
Nope, this is equals.
Equal,
Yeah, inside here, right here, inside, could be a 12 inside there, because the absolute value of 12 is 12. Or the inside part could also represent what?
Wow.
Negative 12. Because the absolute value of negative 12 is also 12. So you have two equations. This inside, as I'm hearing, could be that, Professor. Or the inside part could be representing negative 12. The absolute value for both those is 12. Both would work. And you gotta solve each one. You gotta solve the first one. We got x squared plus x, move that 12 over. Glad we had time to do this little review, guys. Is factors, I think. X plus 4x subtract 3. Split this up. Do not let me make a mistake. At this point, I have those two answers. Is that true?
Yes.
Now let's jump over and try the other one. X squared plus x, move that 12 over, comes to plus 12. Move that negative 12 over. That one will not factor. Now if I try quadratic formula, if I should try it, and if I say find the complex zeros, you say, well, Professor, does that mean you open it up where maybe an I comes in? Let's see if it does. Negative 1 plus minus square root 1 subtract 4 times 1 times 12. That's a really strange answer here. All over 2. That's quadratic formula.
So negative 47.
It is. Negative 1 plus minus square root, what was it, negative 47?
Yeah.
All over 2. And too bad that's not a 49. It's a 47. So what's the best way I can express this? Negative 1 plus minus what? I out front, sure it's imaginary. Square root 47, which I can't do anything with, all over 2. That's the best I can do with that. Okay, so watch out for the equations. Now we have just a little bit more here on the equations. Beautiful, here goes. Next one looks like this. All over the board here. I brought in this. Absolute value, 8 subtract 4x, less than or equal to negative 13. Let's call this part D. Another example. Anyone remember how we dealt with absolute value inequalities?
That's what minus 13
You put it between 0 and minus 13.
Okay, I'm hearing that, I'm hearing that, I'm hearing that. I love, that's what I like teaching, I'm hearing that. Yes.
Can't the absolute value never be less than a negative?
no solution. No solution. Give it to me. Absolute value, this right here will also always give you what? A zero or a positive. Is there any number out there, positive number less than -13? Well, of course not. Any positive number equal to a -13? Of course not. No solution. And all of a sudden you turn your papers in, you got half a page of work done, say, oh, professor, I felt good about this problem. You did. You see me leaving after class, professor, what's the answer? I thought I did half a page of work here. I know I did well. Answer, professor. No solution. Have a good day. No solution. Are you kidding? Okay, but watch out for that test one. C. Got a solution on this one. See if we have a solution here. Absolute value. 1 subtract 4x. Now finish this review up. Less than 5. This one can be done. Now, if you look back to your notes, and I know you will in preparation for this test, I give you 2 rules to follow. One was if the absolute value does this, it meant something. On the other hand, if it does that, it meant something. If you want to recall what absolute value of x greater than a, what did that mean? And we did some work in class. Yes.
It means that x is less than negative a and x is greater than positive a.
Whoa, perfectly said. And that's what I would use to set this up if it were that. Mine though is a less than,
Smaller or equal 0.
not 0.
It's negative a is less than x is less than positive a.
Probably written like this,
Yeah, it's like split.
right?
Yeah.
That's what we looked at in class. It's in your notes. I know June sent all this out for sure. So guys, I'm gonna apply this to mine. Here's what I need to do. Now be careful. It says negative a, that's -5 in my case, is less than the inside part, 1 subtract 4x, less than 5. Do we agree?
Yes.
Is that what it means? And then you solve it. You first had to write it out as by definition. Solve this, guys, be careful. I'm gonna subtract 1 first. Be very patient. And here we go. Got -6. Less than, these cancel. -4x. Less than 4. Bring my work up here so you can see it. -6 less than -4x less than 4. And then you would suggest what to do next to get the x.
You divide by -4, then
Oh,
flip the
wow.
sign.
By everything by -4, perfect. Now what must I be careful about as I do that?
You flip the sign.
Ooh, wow. Okay, this is positive 3/2. We'll reduce it down. Reverse the symbols, this is,
Greater
give me x in the middle.
than -4.
And what was that over there?
-4.
-1. Ah. Right?
Yeah.
Now, can anyone tell me, look, I know this might make it a little strange, but can anyone tell me, and I had to reverse the symbols, can anyone tell me what that might look like in interval notation? I know it's written a little awkward. Can you tell me in interval notation, what might that be to?
Open parentheses, -1. So 3/2.
Thank you. It means that. Written a little differently, but it means that. X is caught between those 2 numbers. Wow. I got one more. Here we go, the last one looks like this, absolute value, call this, there's a T here, yes. I'll move the word here. Last one, absolute value of 3x plus 4, I don't think I've done this one yet. It's greater than 2. think that's it. It is it. That's it. So we're here. And then we'll try this one. By definition, that one looks more like this form. You guys agree? The last one has a greater than symbol, but this one has a greater than symbol. So now, can someone be clever and tell me what, based on this, does mine look like?
3x plus 4 is less than negative 2.
Whoa, hang on. 3x plus 4 is less than a negative 2, or?
And then 3x plus 4 is greater than a 2.
Andrew, did I score that test? It is better. Better. You know, almost, I hope perfect. With all these responses, if you run those responses in class today, he is ready for it. You wrote this out perfectly for me. Now solve each one of these. This is 3x is less than, or is that negative 6?
Yeah.
And then x is less than negative 2. Put a 4 in there. The next one, when I solve it, 3x is greater than, looks like negative 2. And x is greater than negative 2/3. Now, I will ask you to put it in interval notation. Go ahead and solve it. You get lots of partial credit. I'll say, please place this answer in interval notation. When you say x is less than negative 2, guys, please tell me, are we talking about an interval that looks like this? That was the union symbol. And now here, what? Negative 2/3 to infinity. And that's your answer. Oh. That's what the test is going to cover. I would think, I don't know, are you guys more concerned about our professor's going to do here?
Yeah.
A word problem. Now, I may stick with that fencing, I may stick with that stone being tossed up in the air or whatever happened there, and the height and the time, that's one students love. Not the maximum height, I think the time it takes to get there, the time it takes to hit the ground. Okay, this one requires a bit more thinking. Guys, we have worked hard. Now, I hope you have a better idea now what that test is going to do tomorrow. Now, keep in mind the handout you picked up last night, that's still on there too. Almost missed. I'm gonna be here at 11:30. That room should be packed. I'll be here at 11:30.
Oh, are we hitting your?
Oh, whoa, I got some busy